Hello, everyone, and welcome to our new DevNation Java Tech Talks on Fridays. And today I'm super excited because we're going to have like two of my favorite subjects. First, we're going to be talking about Quarkus I/O, and we're also going to be talking about Reactive. And the special guest today is my dear friend Clément Escoffier, which is a French guy. You can tell by the name. He's a wine lover, and he's also one of the world's top reactive experts. So let me share the stage with you, Clément. Please go ahead.
Thank you, Edson. Again, my name is Clément Escoffier. I'm working at Red Hat. I'm doing a lot of reactive stuff at Red Hat. And today I'm really excited to have the ability to present Mutiny, a project that I've been cooking for a few months. And it's a novel reactive programming library that we have integrated in Quarkus. This is a result of almost 5 years of work around reactive and analyze all the practice, all the pitfalls we have seen when developers and mainly enterprise developers try to use reactive. So we will see how it looks like. But the first question is, why does reactive matters? Because we have a lot of things about reactive these days, but most of them does not really explain why it's actually an issue. The root of the issue is distributed systems. Today, most of the systems you are building are distributed systems. Why? Because as soon as your code is doing an interaction with something outside of its own process, like sending an email, like interacting with database, like calling an HTTP service, it becomes a distributed system. Tricky thing about distributed systems, and we know that for now a long time, that they are very challenging to build and to maintain. So it was hard, and now it's become even harder. Why? Oh, it's not a question of technology. Scorba was fine a few years back. It's a question of usage. Everything has changed on how your system is going to be used. The first thing is the users. A few days ago, I had a call with the customers that I visited 2 or 3 years ago. And 2 or 3 years ago, they said, oh, we don't care about reactive. We are not at this scale. We don't need this user experience. And they call me back, they say, okay, so it's escalated quickly. We really need to find a solution. The trick is, what they realize is that most of the people now have been used to what I call the Google experience. Something that is blasting fast and never fail. And now you need to approach this kind of experience. So be as close as possible of providing this user experience. Users are picky, they want the data to come to them and not fetch it anymore. They want something fast, they want something reliable, so it's pretty hard to build. Second thing is that IoT and mobiles are changing the game. These things are never sleeping, so they are always sending events, message, requests to your system, so your system is really struggling to by the load, so you need to find some way to do this. And then finally, the event-driven things. These days, there is a lot of events. You probably heard a lot about Kafka since 1 or 2 years. Kafka is becoming the cornerstone of any modern systems. And Kafka is what? It's just a way to take events from A to B. So every time you use Kafka, it's a lot to do with event-driven architectures and events. So how does Reactive help to build such kind of systems? Well, the first thing is that Reactive is going to embrace non-blocking I/O. By doing this, you are going to use the resources more efficiently. Instead of using one thread per request or one thread per event, you are going to use one thread to handle multiple concurrent requests. As soon as one request needs to do an outbound call, like calling a database or calling a remote service, it's going to release the thread, and so the thread can be used to handle another event or request. Thanks to this, you can handle more load on the current set of infrastructure you have, and so you will reduce the cloud bill or optimize the deployment density you already have. It also improves the responsiveness, so a step closer to the Google experience, in the sense that you get way more concurrent users at the same time. The second part of Reactive, which is really important today, is these event-driven flavors. What I mean by event-driven is the ability to write code like this: on event X, do Y. That's key when you have a lot of data-intensive systems where you need to process data that are coming from IoT devices or mobile phone, and you need to react quickly to that. So how does Reactive work under the hood? Well, in the Java world, It's probably a Netty layer on which you have a reactive framework. Netty is an amazing toolkit, non-blocking IO toolkit. It's really low level, and it's so low level that a lot of reactive frameworks have been built on top of that to make it a little bit more easier to use. So all the network part is going to be handled by Netty, and then you have this reactive framework that will take those primitives provided by Netty and make them usable. Netty is going to use an event loop, what we will call an IO thread, and the reactive framework will be called on this IO thread. And your code is also going to be called on this IO thread. So you see it coming, right? If it's come on the IO thread, how do I do to handle, to write code that blocks? You can't, because if you start blocking the IO threads, all the promises from Reactive just fall apart and collapse. So you must not block, never. And here is the tricky thing. How do I tame the asynchronous beast? So let's take two extremes. The first one is callbacks. Callbacks are very simple, clean. You really see this event-driven nature here. So for example, this is some vertex code where you attach a request handler, and every time that the HTTP server gets a request, this is called. So we really see this event-driven manner. On request, do this. Tricky thing with callback is that it doesn't compose well. So very quickly, you end up writing such kind of code, and it's really hard to read, hard to reason about. Indentation is a nightmare, so it doesn't really scale well. On the other side, you can use reactive extension and reactive programming, and so use asynchronous data streams to manipulate asynchronous objects, asynchronous action, and compose them. Reactive extension defines a lot of different operators, so you can compose almost as you want your operation. There is a few issues with this approach. It's hard to learn, and very quickly you end up with a map/flatmap jungle. And we have seen developers writing nice code, very elegant, and say, oh yes, that's pretty nice, I love it. And then 1 week later, coming back to the code and say, what did I try to do here? So the fact that it kind of abstract your logic, it makes your logic not necessarily easy to follow, is really, really hard to read and hard to maintain. And the gap for regular developer to write such kind of code is really, really high. We have seen that. We have trained a lot of reactive developers over the last 5 years, and they're really struggling learning and understanding this. So let me now introduce Mutiny. Mutiny is a novel reactive programming library that, as I said at the beginning, analyzed during the last 5 years everything around reactive. What we wanted to do with Mutiny is to have really an event-driven API. So the API will be composed with on item, on failure, on completion, on overflow, and so on. So really on something, do that. The API, we want it to be navigable. The tricky thing is that when you implement reactive extensions, we define a lot of operators. It ends up with classes with hundreds of methods. And some methods have dozens of overloaded variants. So we have seen developers in their IDE trying to scroll in this list and trying to understand which one they need, picking the ones that match their signature or their expectation, without really understanding what it was actually doing. We wanted to avoid this. So, and last thing, we want to focus on your logic, how you are going to express your processing, your logic, and avoid any mathematical concepts. So in Mutiny, you are going to write such kind of things. So let's imagine that you have an asynchronous service called service where you can order, you get an asynchronous result that we call a uni in Mutiny, and then you say on item, do this, on failure, recover with that, and so on. The subscription block is very important. It's what triggers the computation. By default, everything is lazy and can be reused, and the subscription is really what triggers it. So then once you have this, the events are going to flow in your pipeline, and you will be able to handle all the events that have been triggered. Mutiny comes with two types, uni and multi. Uni is for one item of failure, It's perfect for asynchronous operation. It provides all the composition construct you need for this. And then multi. Multi is for data streams. You can have 0 to n items, and it supports back pressure. What I mean by this is that multi implement reactive streams publishers, so you have the reactive streams back pressures. Depending on which type you have, you don't necessarily have the same type of events, but they are mostly similar, and the API is mostly similar. Okay, so what we also learned about Reactive over the last 5 years is that the one good way to let you explain what Reactive is and how you use it is to show it in action. And that's what we are going to do now, and we are going to build this system. So first, we have a Mongo database, which has been pre-populated with super heroes and super villains. We have the subservice that will use this Mongo database to expose some asynchronous REST endpoint. Then we have a fight service that will call the subservice to get a hero, get a villain, and make them fight. The outcome of this fight is going to be sent to the browser and sent to Kafka, where on the other side, we have a stat service that will collect them and compute some statistic about that. So let's now switch to my code. Here it is. So I have my three services are all Quarkus applications running in a development mode. So I will be able to write my code and it will be automatically refreshed. So here we have the subservice, the fight service, and the stat service. And this is my first resources from my subservice. And what I can do immediately is to do something like greetings, public uni strings, let's call that greetings, and return some uni directly from an item that I know, like greetings. So if I do that, what I mean by this is I'm creating a uni created from this item greetings. So let's try this. Oops, /greetings. Okay. And it works. So we had seen the recompilation on this screen here, and so now it should be much faster because there is no recompilation. Tricky thing here is that doesn't make any sense. We know the response, so why we do it in an asynchronous and reactive manner? And you're absolutely right. So let's now switch to the villain class. Villain is using what we call a reactive panache Mongo entity. So it's connected to Mongo and is exposing a reactive API. And Quarkus reactive API means Mutiny API. And what I want to do here is to pick a random villains for my villains collection. So first thing I will do is get the number of villains that I have. Then on item, I will pick a random one. So in this count, so I will do random.next in value. So now I have a random one in the bound, so between 0 and count. And now I will retrieve it. So on item, produce uni. This is my index. And here I will return find all. And one way to do that, there is multiple ways to do that, but it's actually to do to get the page that start at the index and get one result. And here we go. I will remove this, return that, and we have our way to retrieve a random villain. So again, we retrieve the number of documents. This is asynchronous because it called with the database. Then come back. Once we have the result, we pick a random number, and then we retrieve the villains from the database. So if you are used to reactive programming, you say, what are those methods? I'm not used to that. I'm used to mat and flat map. I have a good news for you. You can just do map and flat map here. So obviously I need to change a few things. This is hero, and that should be enough. Yes. So while we support this on-item and event-driven approach, we also support map and flat map and a couple of really well-known operators. However, be aware that if you are training them too much or nested them too much, it makes your code not necessarily nice to read. So be careful when you use them, but we provide them. So now that I have these two methods, let's use them here. So let's create slash error that will return a uni of error. And here I'll just do error dot find random. Okay, I'll do the same with freelance here. And here. So let's try this. Can I get an hero? Yes. Can I get a villain? Yes. So I can get heroes and a villain. So each hero and villains have an image, a level, and a name. What I can do now is also getting a stream of heroes. So for example, I can do, a get that will return, that will be on slash heroes. And I'm going to return that as an SSE. So server-side, server-sent event. So we are going to stream the result to the client. Each event is going to be a JSON object. Okay. And now I will return a multi of error. And let's say that I want an error emitted every second. So I create a multi, create from ticks every seconds. And every time that I have a tick, I'm going to retrieve an error. And I need to return that. And here I need to merge. So this last part is actually interesting because we will trigger many asynchronous actions and we have two choices. Either we don't care about interleaved results or we care about, or we want the ordering preserved. Merge doesn't care, concatenate, preserved it. So now that we have this, I can do stream and every second, I call that errors, of course. Every second, I will get a new error. So again, every second, we have a tick that trigger an asynchronous action that go to the database and retrieve it. So let's now switch to our second service, the fight service. So the fight service is going to call this subservice, get a error, get a villain, and make them fight. To retrieve that, I'm going to use a microprofile REST client. So this is a subservice client that has been connected to my applications. And I retrieve my random hero and my random villain in an asynchronous manner. So see, I'm already returning uni here. And now in my resource, I just need to do hero equals subs dot get random hero. But it's a distributed system, so things can fail. So I need to be a little bit more careful here. So let's say that if I have no item after duration 500 milliseconds, then fail. Okay? And on failure, timeout or not, whatever type of failure, you will recover with hero.fallback. So I will do the same with villain. Get random villain. And at that point, nothing has been done. I just represented my request, but they are not really executed. And I want to emit them, but not one after the other one. That would be a waste of time. I want to emit them at the same time, and when both replied, compute the outcome. So I will do this by creating another uni that is a combination of all unis, here, hero and villain. And I will combine them with a method that I already wrote, which is compute fight outcome. We don't need this anymore, and I will return that. So this method is very simple. It just take my hero, take my villain, do some random things, and decide who is the winner. Nothing very smart behind this. So, but now with this, if I try to call it here, we got the selected heroes, the selected villains, and the winner, which is just the name of the heroes or villains that are won. So I can do that a couple of times. So that's pretty nice, right? It's actually how I compose asynchronous actions very, very nicely. And here, every time I do this, it calls a subservice twice, get both results, call another service, another method, and return that. So one thing we can do with this, following the same thing, I can also get a stream of fight, which every second will do exactly the same thing, get a hero, get a villain, and make them fight. And this is the same trick I did earlier. So I get a stream of ticks every second, and for every second, I just trigger a fight. One thing I didn't mention yet is that my compute fight outcome is actually sending the results to Kafka. How is it done? It's done using microprofile reactive messaging and an emitter. And every time that I get a fight, it writes this fight to the channel fights, which end up being a Kafka topics. So now I can, on the other side, in another microservice, consume those fights that comes from the fight channels and do some computation on top of that. So this is again using microprofile reactive messaging. And here I get my stream of fights and I need to produce a streams of stats. So fights, on every fight, I'm going to scan. So that means accumulate the results. I need a structure that is going to be stats structures, which is just two counters. You see the details here, one by heroes, one by villains. Okay. And once, and every time that we have a fight, we are going to call this compute, this compute method and return this. So again, what does it do? Every time that it gets a fight, it adds this fight, it accumulates this fight with the statistics we have and just updates the counters. So now if I go there and I do, oops, the stream. Okay, so at the beginning I have 0, 0, and then because it's Kafka, it's going to replay all the fights we already played. So 1, 6, so wow, the villains are definitely winning. 7 against 1. So let's try a few more fights to see if we can try to get better things here. 4 against 9. Well, okay, so we cannot let that like this. So heroes must win. So we are going to help them. Remember, in the fight service, I have written this code here. And one thing I know for sure is that the villain fallback is actually not that good in terms of level. It doesn't have a lot of power. So if we can make the random villain method a little bit too slow, then we are going to use the fallback, and then heroes have a higher chance to win. So let's do this. I go back to my subservice here. This is the method I want to make slower, and here on item, delay it by 1 second. Something like this. So again, it's very fluent. It's very clear of what you want, what you mean here. I'm going to delay it by 1 second. So now, if I trigger some fights, so we see that it's mini TX, the villain fallback that is used because we are after the deadline, after the timeout. So that means that the heroes are always winning. And here, heroes are now 11 against 9. So what we can do too is to close the subservice. We close it, and I can still trigger some fight. And by doing this, I get both fallbacks, the fallbacks of the heroes, which is Donatello, Turtle Ninja, and Mini TX for the villains. And so we can for sure it's going to win. And yes, so now heroes won 14 against 9. There is a few other things that are interesting in Mutiny, like how do we test? Typically something that we can do in test because we are not allowed to block in your code, but inside your test you could do that. And blocking is done like this: await indefinitely, or await at most, and you give a duration. So that also helps a lot testing your applications. In reactive messaging, we also have an in-memory connector that lets you avoid having to use Kafka in your test. So we have plenty of things around that that are already delivered. I will switch back to my slides. Here. That's all I have for you today. We should have a few minutes for questions. If you are interested by Quarkus or by Mutiny and how Mutiny has been integrated in Quarkus, go to quarkus.io. Almost all the services, all the APIs Quarkus provides have a Reactive API that is now using Mutiny. This also includes every client from Vertex, the engine of Quarkus, have a Mutiny API. If you want to start coding, and I can totally understand that, code.quarkus.io, you generate your project and you're ready to go. You want to interact with the team, Quarkus does not only innovate in terms of technologies, it's also innovate in how you interact with the team by using something called Zulip. If you never heard about Zulip, it's a lifetime experience. The first week is kind of interesting. After that, it's really great. You will love it, but yeah, the first week is weird. You can follow us on Twitter. And if you like Quarkus, if you like what you have seen today, go to this last URL here. It's a code from Quarkus. Give us a star. It's totally useless, but it makes us, the Quarkus team, very, very happy. And that's it. So, Edson, do we have some time for questions?
Yes, Clement. Well, thank you very much for this very nice presentation. I'm pretty sure we'll get a lot of GitHub stars. And first question, W. Frank is asking, will the Mutiny stuff run in the worker thread of JAX-RS or the Vertex IO thread? So what if the internal operations are blocking?
So this is a great question. So by default, when you do a JAX-RS endpoint, it's going to be called on a worker thread. No, Quarkus provides this, but also provides something called reactive routes where you will be called on the IO thread. So you decide what you want to do. If you really are looking for high concurrency, go for reactive routes. If it's okay, go for the regular worker thread approach from JAX-RS. We have published on the Quarkus blog an article explaining the difference and why and what the concurrency difference. So go to the blog from Quarkus and you will have all the details.
Okay, and I think it's related to the same subject. Is there anything that I should not be reactive, or can everything be reactive from Vinicius?
Well, of course, if you have a very blocking logic, heavily CPU intensive, which will take few minutes, let's say 3D modeling or something like that, then yeah, it's not IO bound. So in that case, reactive won't help much. As soon as you have a lot of IOs and it's actually really receiving requests, calling other services, reactive is definitely helping a lot. One thing to say is that Mutiny support context propagation, so you can use transaction with Mutiny. So before that was the thing, oh, you cannot use that. You can use transaction with Mutiny.
Oh, that's nice. So since we're talking about transactions, Alekos is asking, so does it make sense to combine Mutiny with Hibernate because of blocking JDBC?
So that's again a great question. So yes, Hibernate by default is using blocking JDBC, and that doesn't really make sense. Well, you can still use it. We have things to make you use it in Mutiny, but yeah, I agree. You lose a little bit the advantage. What is pretty nice is that we are working on a reactive version of Hibernate that will avoid this, and that will be based on reactive drivers that are totally non-blocking and reactive. So stay tuned, it's coming.
Okay, and Julio Cesar is asking, what is the best way to handle client disconnections?
Client disconnections. There is a few things you can do here. So let me write some code. So that won't really fit in this demo, but for example, on a failure, you can retry. So reconnect. Let's say you want to retry with some backoff, for example, duration of seconds 1 and duration of second 10, something like this. You can also add a jitter if you want, or .2, or something like that. So retry is already built in. You don't have to do anything. I'm not sure that I'm going to increase this. Okay, so you can do retry. You can also do, as we have seen, recover. You can recover, retry, and things like that. So it's going to be handled like this. One interesting aspect too is that you may want to do a cleanup when the action is cancelled. We also provide a way to do this, like on termination or on cancellation, you can execute some cleaning code. Again, you really see this event-driven nature that we wanted to infuse at the core of Mutiny.
Okay, and Thiago is asking here, will Mutiny replace reactive streams operators, or will they both coexist and can be integrated?
So reactive streams operators is a spec from microprofile, but it's a spec, so it's a set of interfaces. Mutiny is really more a library, so that it's not a spec yet. We are starting discussing whether or not it will make sense to provide a spec on top of that. It's not. We didn't take a decision yet. One thing is that I have re-implemented reactive streams operators on top of Mutiny. So now I have two implementations. I have the first one I did a few years back and one which is based on Mutiny. So they can work at the same time. There is no problem with that. And you can decide which one you want. I strongly recommend Mutiny because actually reactive streams ops is what makes us realize that something was not great. So for the developer, it was still too hard to understand, too hard to read, and too hard to maintain.
Okay, I think we're on the top of the hour. So the last question is from Alexander. Does JUnit support reactive stuff tests?
So when I need to test reactive things, I can use the await operators that I show you. So await at most and indefinitely and things like that. So I make it blocking. I know, but I'm in my test, so that's fine. I'm okay with this. Or I recommend awaitility libraries, which let you do almost the same thing, await until a condition is met. If you plan to do tests for event-driven microservices like Kafka, M2P, or whatever, we have something called in-memory connector, which actually substitutes itself to Kafka or something like this. And you can say, okay, I'm sending message ABC to this method, and I'm interested to see what is the outcome. And then you have all the primitives to retrieve the outcome and say, okay, that's the right processing that we expected or something like that. So we provide a lot of test utilities to do this. Even inside Mutiny, we provide test subscribers and things like that, the await that we have seen, and a couple of other things like this.
So basically, if you have a code and you want to test it, make it blocking.
Make it blocking to let you write it easier. The tricky thing is that it's generally easier to reason about, and tests can be very, very complicated. And if not, then just use awaitability and keep it on blocking, and at the end, just wait until the completion.
Nice. I think we ran out of questions and we're out of time already. So, Clement, I would like to thank you again for this very nice presentation. I think the audience is as excited as I am about Quarkus. And of course, now they should be excited about Reactive and Mutiny. So thank you very much and hope to see you again in our next DevNation Java Tech Talks on Fridays.
Thank you, Ethan. Thank you for having me. Bye.
Bye.